Alrighty, welcome to video 8.3, multiplying polynomials. In this one, there's not a lot of vocab, but there's going to be a lot of explanation for how to solve the problems, because there's three different ways that we can do that. So, the first is just vocab. What is a quadratic expression? This is any expression with a variable of degree 2, which means squared. So it could be x squared, y squared, anything like that. And this is a contrast to a linear equation, which is to the first power. So when you multiply, so let me just say here, linear is like y equals mx plus b, right? So the y is to the first power and the x is to the first power, so the highest power is 1. When you multiply two of these linear expressions together, you're going to get something squared, which is a degree 2, which is called a quadratic expression. So throughout this chapter we'll go more and more in depth into what a quadratic expression is. So first let's look at how can you multiply quadratic expressions together. So this is called multiplying polynomials. There's three ways to do this. The first we call FOIL, which stands for firsts, inners, outers, and lasts, and this works for binomials only. Okay, so suppose we have a binomial which has a first piece and a second piece, and then we have another binomial which has a first piece and a second piece, and we're multiplying them together. So I'm just going to put in some easy things, 3x plus 1 and x minus 2, just for the sake of making this as an example to kind of show you what the procedure is. So you write down FOIL, which stands for firsts, outers, inners, and lasts. Sometimes I write it down like this, FOIL. Okay, and now we're going to multiply together each of these four possible combinations. So the first thing here and the first thing here is 3x times x. That's 3x squared. The outers are the two things on the very outside. So we've got 3x and a negative 2. 3x times negative 2 is negative 6x. The inside is right here. 1 times x is just 1x. And the last is going to be the last thing here and the last thing here. So 1 times negative 2 is negative 2. Then once we have the four pieces, we add them all together. And notice that we can combine these together. So the first term, the highest degree, is 3x squared. The two in the middle combine together to give us negative 5x. And then the last one is negative 2. And that's our answer. So this option, just remember the word FOIL, and it reminds you firsts, inners, outers, and lasts, or firsts, outers, inners, and lasts if you spell it correctly. And you can go through and pair up each of those four combinations, write them down, add them together, and get your final answer. Okay, the second way or method that you can do this is just distribution. It's called double distribution or multiple distribution, I guess. So every single term in the first polynomial distributes to every single term in the second polynomial. The reason this makes sense, let me make another simple example. So you have x plus 7 multiplied by 2x minus 5. Okay. You could think of this whole thing, let me have a different color real quick. You could think of this whole thing as one piece, and you're distributing it here and here. So if you did that, you'd have x plus 7 multiplied by 2x, and then you'd have plus x plus 7 distributed to the second thing, which is a negative 5. Okay, and now let me switch back to the red. And now this distributes here, 1, 2, and 1, 2. So you have x times 2x is 2x squared. 7 times 2x is plus 14x. Here we have negative 5 times x, which is negative 5x. And here we have 7 times negative 5, which is minus 35. Again, notice the two middle terms add together, and your final answer will be 2x squared. 14 minus 5 is 9x, and then negative 35. And of course, that's a positive 9x, so positive sign. Okay, so why does this make sense? Because you can distribute multiple times, aka double distribution. But more importantly, once you do this, you should realize that this term right here was my f, first times first, first times first. This term right here was my inside times my inside, so we'll put a little I right there. This term right here was the last times the first, which is the outside pieces. and this one right here was the second thing times the second thing, so last times last. And it's spelled wrong, but it's still the same four pieces, F-I-O-L or F-O-I-L. Doesn't matter what order you do them in, because you're going to add them all together. So this distribution is equivalent to the FOIL method. Now, I've shown it out why it works in that example. Let me do one more quickly here. I'll do it very quickly. X plus 2 times 3x minus 9. Okay, when you actually do this distribution method, you don't rewrite it like this, okay? You take this arrow and you go here, and you go x times 3x is 3x squared. Then you take this arrow and you go here, x times negative 9 is negative 9x. Then you take this arrow and you go here, you go plus 6x. Then you take this arrow and you go here, and you do minus 18. You recognize that these two can be combined together, and you have 3x squared minus 3x, because these combine together. Negative 9 plus 6 is negative 3, and then minus 18. Okay, so there's your final answer. It's actually pretty quick, and when you draw on these arrows, you recognize and make sure that every single piece in the first polynomial distributes to every single piece in the second polynomial. And this is the method that I personally prefer when I'm doing this kind of work. Okay, the third one is called a rectangle diagram. And if you remember from science class, it's just like a Punnett square. Okay, so this is kind of cool. Say we have x plus 2, and we're multiplying by 3x minus 5. Okay, what you can do is you can make a 2 by 2 square, just like a Punnett square. And across the top, you can write one of your two pieces, so x and 2. And then down the side, you can write the other one, so 3x and a negative 5. So you're making sure that you hit all those same possible combinations, but here you're laying it out like a square. So each square gets multiplied by the row and the column. So here we got a 3x times an x, which is a 3x squared. Here we have a 3x times a 2, which is a 6x. Here we have a negative 5 multiplied by an x, so negative 5x. And then here we have a 2 multiplied by a negative 5 for a negative 10. And just like FOIL and just like distribution, we add up all these terms. So 3x squared. Now these two here are like terms, so they can combine together. 6x and a negative 5x combines to be positive 1x, and then I have a minus 10 left over. Okay, so this is a rectangle diagram. Now if you think about the three methods, you might have in your mind a preference of which one works better. Let me go back to the first method here. Remember that FOIL only works, F-O-I-L, if you're doing binomials, okay? This method, distribution, even if this one had 3 terms and this one had 4 terms, you could still distribute every single possible thing here to everything possible here, and you would get a lot of terms in your answer, but the method works for any size polynomials. Likewise, these squares, say you're multiplying a binomial times a trinomial, you can do a binomial times a trinomial by making 2 rows and 3 columns, okay? So this rectangle diagram method and the distribution method works for any size polynomial, and FOIL only works for a binomial times a binomial, so keep that in the back of your mind. Okay, if you multiply 3 or more terms together, so if you have now 3 things multiplied together, and each one of them is a polynomial, pick 2 of them and multiply. So start by just multiplying these 2 together using one of the methods that you learned. Then once you get an answer, now you have some big answer here, and this third one stayed the same, you can multiply your answer by whichever is here. And you can reorder them, do them in whatever order you want. So if you want to multiply these 2 together first and then go by this one, it doesn't matter. Because multiplication is commutative, you can change the order of the entire term with another entire term. But the key is if there's 3 or more pieces, you just pick 2 and ignore the third one, work out the result, and then incorporate the third one. Alright, let's do some examples. I'll do the distribution method for this one here. We'll do number 1. So distribute the m onto the m, and you get m squared. Distribute the m onto the 1, you get plus m. Distribute the 4 onto the m, you get plus 4m. Distribute the 4 onto the 1, you get plus 4. These 2 terms can be combined, and we get m squared plus 5m plus 4 as our final answer. Okay, let's go over here and do this one. Here I'll do a rectangle diagram. Okay, so we got a t and a 4 across the top from this one. We have a t and a negative 3 from this one. T times t is t squared. T times 4 is 4t. T and a negative 3 is negative 3t. And negative 3 times 4 is negative 12. Okay, I add up all these pieces together and I get t squared. These two diagonals combined together, 4t minus 3t is just plus t, and then minus 12. That's a different way you can do it. Let's do this one here. I'll do FOIL, so I can write out FOIL. So F is first, so first times first. 3c times c is 3c squared. Outers is 3c times negative 2, which is negative 6c. Inners is this one times this one, 1c. And last is 1 times negative 2, which is negative 2. Okay, now I combine these all together, and I get 3c squared. The 2 in the middle can group together, so negative 5c plus 1c, negative 6c plus 1c is negative 5c, and then I have a minus 2 at the end. So I hope you can recognize that actually all of these methods, whether it's distribution, whether it's a rectangle diagram, or whether it's a FOIL, they all accomplish the same thing. They all mathematically are equal and identical, but they're a different way of conceptually thinking about it, and so whichever one of them suits your style the best, you're welcome to use, as long as you remember that you can only use FOIL on a binomial but not anything larger. Okay, here's a couple more examples of, now we have a binomial here multiplied by a trinomial. So I'll try distribution, k to the third power, then 3k squared, then negative 6k. Now here's another good hint, is I could keep going in this row as I distribute the 4, but I like to line up the terms that have the same power, because I know later on I'm going to have to combine them all together. So now when I distribute 4k squared, I'm actually going to write it underneath 4k squared. Then I'll distribute here plus 12k, and then I'll distribute here minus 24, and then I'm going to add them all up. And now if I've lined them up properly, it becomes extremely easy to add them because they're already aligned with the like terms. Add these together and I get 7k squared. Add these together, I get 6k, and here minus 24. Okay, so distribution like this is very nice. For this last one, I'll do a rectangle diagram, and you'll see it really is completely equivalent to this distribution method. It's just showing it a little bit more. So here I've got an m and a 3. Across this way I have m squared, 3m, and 5. So when I multiply these two together, I get m cubed. That was basically the same as this step of distribution. Okay, then I multiply the m by the 3m, and I get 3m squared. That was the same as this distribution. And now I multiply the m by the 5, and I get 5m. That was the same as this distribution. Now I move on to the 3, and I basically distribute it in 1, 2, 3 times. So 3 times m squared is 3m squared. 3 times 3m is 9m, and 3 times 5 is 15. And just like I had terms that match up right here and match up right here to be combined, these guys match up and will combine, and these guys match up and will combine. So my final answer is m to the third power right here. These add together to give me 6m squared. These add together to give me 14m, and then there's a 5 left over. Okay, so when you're doing this kind of distribution, whether it's single variable, multivariable, binomial, trinomial, try the different methods, figure out which one works best for you, and go through the steps. Alright, that's all I have.